For our next example, we once again want to take a look at calculating the class average, but this time we want to demonstrate, rather than sequence-controlled iteration, Sentinel-controlled iteration, where we don't know in advance how many times we really want to loop. And this is the type of iteration that you would use, for example, if you were reading values from a file and you don't know how long the file is, you keep reading until you reach the end of a file. Or if you're receiving data over a network connection, you might keep reading until you get some sort of indication that there's no more data to read. So the concept of Sentinel-controlled iteration is important in Python as well. Now, before I go through this script, let's go and execute the example so that you can see it in action. So I'm going to switch back to my terminal window here. Again, I'm already in the folder that contains the script we're about to look at, fig03_02.py. So let me go ahead and run that with the IPython command here. And you can see it's prompting me to input a value. So let's say I type 97 and press enter, and let's say I type 88 and press enter, and let's do 72. And now you'll notice, by the way, it's telling me specifically to input -1 to end. What that is the Sentinel value, a flag value of some sort that's not a valid piece of data, but is something that can be used to tell the program when there's no more input to process. So let me go ahead and type -1, and when I'm done, it displays the class average. Notice, by the way, it's displaying 2 digits to the right of the decimal point. We're going to introduce how to use what are known as format specifiers in f-strings in just a few moments here. So let's go back over to the code and see how we implemented that. Now, once again, just like in the preceding script, we need to keep track of the total, or the sum of all the grades that have been input so far. By the way, you might wonder why I haven't named this variable sum previously. That's because there's a built-in function called sum, and I'm trying to avoid using the same names as the built-in functions. I discovered the hard way that there was a built-in function called sum when I was first learning Python, and I suddenly couldn't use the sum function because I had declared a variable that had the same name. So I'll talk a little bit more about that when we actually get to the sum function in a subsequent example. So anyway, we have the total variable, which is set to 0, and we also have a grade counter variable once again, which is set to 0. Now, in this example, we really do need the grade counter. We're not processing a list of existing values. We are getting one value at a time from the user at the keyboard. So this might be a program that an instructor would use to calculate their class average. Obviously a very basic or simple program for this particular case. So we do need the grade counter because we have to keep track of how many legitimate grades have been input so we can properly calculate the class average. Now, when you're doing Sentinel-controlled iteration, it's not uncommon to input the very first value before you get to a loop that will process all subsequent values, because it is possible that the very first thing that gets input into this program could be the Sentinel value, in which case we don't want to accidentally process that value. So you see here a technique that we've demonstrated a couple of times previously. We are using the built-in input function to prompt the user to enter a grade, or -1 to end the input. That string will then get handed over to the int function, which will attempt to convert it to an integer. And of course, if it is a numeric value, then it will do that conversion. But if it's a string like hello or dog, it will not, and it will fail at execution time. Now, once we've read in that grade, we then check to make sure that value is not the Sentinel value, -1. So remember the not equals operator. As long as grade is not equal to -1, we're going to assume that any other value that gets to this point is a valid grade, and so we're going to add that grade to the total. Then we're going to add one to our grade counter to keep track of the fact that we have a valid grade that we just processed. Then before we go back to the condition, we're going to read the next value from the user at the keyboard. And because that might be the Sentinel, as we come back around to the top of the loop, it will test for that Sentinel once again. If it is the Sentinel value, we'll jump down to line 17. Otherwise, we will process the next grade and then read another value from the user. By the way, notice that I've put blank lines above and below the while statement. The style guide for Python code recommends that when you're writing scripts, you have blank lines above and below your control statements. So down at the bottom we have the last part of our script, which is going to check the grade counter to make sure it's not equal to 0. We do that because we're going to use it as the denominator in a division calculation, and you may recall from lesson 2, divide by 0 is not allowed in Python. It will give you an exception at runtime. So here we want to make sure to protect this statement because it is possible that the only grade that ever gets input is actually the Sentinel value, in which case grade counter will be 0, and this would result in a 0 division error. So we want to avoid that. So average is assigned the calculation of the class average, and we then display the class average, which I'll talk more about in a moment. If by any chance the grade counter is 0, we simply display no grades were entered. Now let's go back to this format string, or F string, that we defined back at line 19. As you can see here, for the first time, the placeholder that we've defined has some additional formatting information specified within it. So again, we're going to take the calculated value of the average and insert it in place of this placeholder. But in this case, we're also specifying a colon and some formatting information. The .2f says that we would like to display this floating point number average with 2 digits to the right of the decimal point. So the decimal point indicates the fact that we're going to provide formatting information about the decimal places after the decimal point, and the 2 says to round the number to 2 digits to the right of the decimal point. If by any chance there's only 1 digit to the right of the decimal point, then you'll also get a trailing 0 in this case. And actually that raises an important point. By default in Python, when you're displaying floating point numbers, trailing zeros do not get displayed. So if you have 7.0, it's not going to display the 0 unless you use output formatting, something along the lines of what I'm doing here, to say I want the trailing 0 to be displayed. So that is our first introduction to a little bit of additional formatting information. This piece right here is known as the format specifier, and throughout these videos we'll introduce lots of other format specifiers as well.